right, I'm gonna record to the cloud this time, and hopefully I won't get quite as laggy. So we'll see how it works out. And share the screen. All right, there we go. Can everybody see my screen?
Yeah.
Okay, nice. So the top voted concept this week was what I was just describing, which is re-implementing a runtime trait, like for example, currency. And so I guess we'll start by just talking about like what these runtime traits are and why they're useful and how you can learn about them, and then what the process of implementing one might look like. And initially I was optimistic that we would be able to actually implement our own full currency in the hour today, but I think that's probably a little bit too much to do in the 1 hour session. So we'll just see how far we get and then follow up however seems best. So, oh, and I guess I'll just use this as a reminder that every week we have these polls about what we want to talk about. So it's definitely not me choosing the topics. It's all of us together. I'm a voter like everyone else. So if you have a topic, yeah. What was that?
I haven't seen it actually.
Oh, you haven't seen it? Oh, yeah. Okay. So let me give a little context about that. I use the same format every week. It's allurideas.org/SCL for Substrate Collaborative Learning, and then the date. And that's pretty hard to remember, but the place that I post them is on our Substrate. So each week I make one of these like posts about the upcoming collaborative learning, and then there's a couple links. One is some people like the calendar invite. One is here, where to show up. I have the recordings on YouTube now, so we can always go back and look at our backlog. And then finally, that one I just mentioned, the place to vote and suggest topics. And when you go, it gives you a pairwise thing to vote about. So you're always just saying like, would I rather do X or Y, Y or Z? And then if you choose one, it gives you a new one. And then the final thing is like, suggest your own topic. Write our own blockchain from scratch, for example. I think I spelled that wrong. Okay, cool. So if you want to vote or suggest topics for next week or future weeks, that's cool. All right, so maybe this is a good place to start. Or actually, a better place to start is how I got here. So I think everybody's hopefully familiar with substrate.dev. This is like our main Substrate developer hub. Lots of documentation, tutorials, and then links to the normal, like our Riot chat and Stack Overflow and everything. And then a new one that we've added since our last session is this one called reference docs. These docs have been available before, but now they're here on substrate.dev. And these are the, we call them the Rust docs. It's the sort of lower level documentation that's really close to code. So it's less like, explaining something at a high concept and at a high level, and more like right there with the code. And the one that I was just looking at was currency. And so it comes from SRML support, so Substrate Runtime Module Library support. And they have a bunch of traits in there. And the one we're looking at is currency. And so maybe before we dig in on currency, I'll just show you traits. So when you're in this sort of like support package, then there's traits, and this is the big idea with traits. When you're building a blockchain runtime, in general, you want to kind of glue together a bunch of these Substrate runtime modules. So the one we're going to look at a lot today is balances. Last week we looked at contracts. I think maybe we've looked at some others in the past through the UI, the Polkadot UI, and in the future we'll look at some more too. And the beauty is like the modules can depend on one another. So like, for example, Kirill, you're writing that poker game. Well, you have to have something to wager if you want to play poker, right? So what did you choose to wager?
Yeah.
So you used the balances module, I guess, right?
Yes, but it will be used only obviously for transferring price for the round.
Yeah, okay, cool. Yeah, that makes sense. So like maybe I make a bet, you raise, I call, some rounds go by, finally you win the game.
Yeah. But actually, my problem is establishing dealing of cards, because if you deal cards into blockchain directly, then everybody can see them. Yeah, so they should be encrypted with temporal key. And when you reveal cards, you should reveal your private key and then generate new one for the next hand.
Yeah, right. That's an interesting point. So let me make sure I understood it correctly. Like the most obvious approach is to just like use the pseudo random feature that comes with Substrate and deal the cards and put them in storage. But then I can like query my node's like RPC endpoint and ask it like, hey node, what cards are in my opponent's hand? And then I like it's not
Yeah, something like this.
yeah.
So every hand secret key should be generated, and it can be also discarded if you don't want to reveal your cards. So this makes like more crypt protection comparing to real life game.
Yeah, totally.
But small problem with encryption is that it is long running task, which is supposed to be not executed while we handling API calls.
Yeah.
So for decent implementation, I should wait for off-chain workers.
I was going to recommend off-chain workers.
Yeah.
Sounds like you're already on the right path. Yeah, that's great.
Yeah, but currently I will work around it with naive implementation of encryption.
Oh, okay. Oh, that's cool.
Just RSA and throwing away every real-world security issues, just very basic RSA.
Yeah, just some like simple cipher that makes it not trivial to see your hand, but like if I put some effort into it, probably I
just for proof of concept.
Yeah, that's a cool idea. Yeah. Okay, cool. So we got on that. Basically, the point was like, you know, if your goal is to write a game like a poker game, you don't necessarily want to write a whole cryptocurrency from the ground up yourself. Like people have done that. It would be nice to use an already existing currency or token, and then you only have to write the poker part. And so that's exactly what these traits like currency are for. So what it allows us to do then is to say like, okay, my poker game is going to need some notion of currency, and we'll just say the currency trait. And then someone else can come along, not knowing anything about poker games or anything else. All they know is they're writing some kind of cryptocurrency, and they'll say, okay, I'm going to implement this currency trait. I'm going to make my module have certain properties like, you know, ability to transfer funds, ability to withdraw funds, things that currencies can normally do. And then even though those two modules were written not knowing about each other, you know, poker didn't know about this particular token and this token didn't know about a poker game, we can glue them together because they've both used this common currency trait. And so right now there's only, you know, there's a handful, half a dozen of them maybe in here, and some of them are kind of similar. You know, we can see that there's like lockable currency on here and reservable currency and just plain currency. But the idea is that we'll have traits for a lot of really common use cases. Like you could imagine in one of the common use cases for blockchain is voting systems. So we might have a trait for something like elections, where the person who writes the election module doesn't know anything about what kinds of elections are going to be held on it, but they've just implemented this common trait. It's kind of like a common interface. And so now those modules can work together. Oh, and in fact, maybe before I even look at the specifics, I'll show how we did this last week back in substrate.dev. So we looked at, last week we talked about implementing, or like basically like installing the contracts module on to a node template. And so I want to just look at that real quick. This one, adding a module to your runtime. And so we went through all of these instructions and, oh yeah, and so at some point we had to do this, right? So we're adding the contract module, which is for smart contracting. But just like we were saying with poker game, it needs some notion of a currency. And so here's what we did. Basically, the contract module says, I need some notion of what a currency is. Some of these are kind of default, and they're a little tiny bit separate from what I'm talking about. We need some notion of gas, just like in Ethereum, like I can only compute so much based on how much gas I give it. And so they said like, Gas, we're just going to use an unsigned integer. That's all we need. And then a couple other things. And so what they said was, the currency that we're going to use, instead of writing our own or something, we're just going to use the one provided by the balances module. And so this is how we can use those traits to like sort of wire different modules together. So, all right, cool. So there's the traits. Let's look at the currency one, the one that we're talking about today. So just looking at the section headings, we have some associated types, required methods, and in this one, we don't have any provided methods, but in general, sometimes you'll have provided methods. And then finally, implementers. So starting back at the top, associated types. So balance is like the super straightforward one here, right? Like it's kind of the most fundamental thing about a currency. All the different people who use the currency have to have some balance, whether it's 0 or whatever. And some currencies might even do crazy things like allowing you to have, a negative balance or something. I was just talking to these guys from the Open Money Initiative, where their idea is like these community currencies where the net balance of the whole system is 0. And then like when you use the currency for the first time, someone gets a positive and I get the same negative if I'm spending some money. So like all of that stuff is abstracted away to your individual implementation of currency. So balance is the big one. And then this is the stuff that I was saying made it a little more challenging than I initially expected to implement this trait. And this is why we're probably not going to be able to get it done in an hour today. So this type positive imbalance, the docs give us a little clue here. The opaque token type for an imbalance. This is returned by an unbalanced operations that must be dealt with. It may be dropped, but cannot be cloned. Okay, that wasn't as helpful as I thought, but I think if we go into here, then we get a little bit more. So one meta point is that you can always click around these Rust docs and learn a ton about like how Substrate itself works. But the big idea about this imbalance is that not all currencies have a constant issuance. So if you're coming from the Bitcoin perspective of like there's 21 million tokens, period, end of story, that's it, then this stuff is almost like not even hardly relevant. But in a lot of other currencies, you might have issuance, like block rewards for miners or validators or something like that. Or you might have whatever the opposite of issuance is, like burning or slashing. If someone does some kind of misbehavior and you prove it and then you burn some of their tokens, both of those things, both like creating rewards and slashing for penalties, change the total issuance. And so this trait about imbalance, and then it's sort of like two types, the positive imbalance and the negative imbalance. Those are ways of dealing with the, total issuance changes. So like in the simplest case, it's not that hard. Like when you burn someone's tokens, then all you have to do is like also update this variable that holds your total issuance, by like decreasing it. Or if you mint some funds, then you have to increase the total issuance. But like we were saying, you can get as fancy as you want.
So basically, this model is more like a depth-oriented model.
So, yeah.
Like if somebody pays to someone, one side gets debt and other gets like benefit.
Yeah. So I think there's like this. The words are a little tiny bit confusing. So I don't think this particular module is allowing like people to have negative balances. I know that the balance module that comes with the SRML is kind of your standard, like your balance has to be 0 or higher. But then this, I think they're using this word imbalance to mean, like when you have something heavier on one side, like this transaction burned more tokens than it created or something. Yeah. So, okay, cool. So required methods. So like, so we talked about what types you have to have. So if you want to build a currency, a module that implements this currency trait, you have to give it these 3 types, and then you have to tell it all these things it can do. So we have to implement all of these methods. Some of them are pretty straightforward. Total balance, and it takes as a parameter an account ID basically, and so that's just going to tell you how many tokens the person has that you asked about. Now, some of this stuff, the currency that we're looking at here, this currency trait, it actually has kind of more features. Like I think I might want to make a new trait called like simple currency or like basic token or something like that. Because we have functions like can slash, and it says same result as slash, but without the side effect. That means like when you call can slash, you're not actually going to slash someone's tokens. You're just going to see whether it would succeed if you tried to do it. Assuming there are no balance changes in the meantime, and the only reserve balance is not, and only the reserve balance is taken into account. Okay, cool. Total issuance, that's kind of what we were talking about before. There's a certain number of tokens that exist in the system. Minimum balance. So this, you know, again, like a simple token wouldn't require this. This is the thing that in Substrate balances module is known as existential deposit. And it's this idea that you don't want accounts sitting around that have the equivalent of like 1 penny in them or 2 pennies in them, because it takes up all this storage and all the nodes have to keep track of, you know, all these tiny accounts that people maybe don't use or forgot about or whatever. So if you want, you can have the concept of like once your balance goes below a certain threshold, then it gets deleted. And that's what this function's for. If you don't like that concept, you can set existential deposit or minimum balance to 0, or, you know, if we do come up with like a simple currency or simple token, then it might not even have this feature. I think in practice, probably like for real world blockchains, this is a pretty good idea, because otherwise the state gets pretty big. Okay, so next, this is another one that just queries the balance of an individual person, but we're asking specifically about the free balance. And the reason is because some implementations, like the one in the SRML, allow you to do things like lock someone's balance, almost in the same way that like you can get a hold on your credit card. So you still own those tokens, but for whatever reason, they're locked up. So like a good use case is in our democracy module, when you want to propose some kind of change to be voted on, you have to lock some tokens behind that, just to, you know, it's a good way to bond people and make sure that they're not like wasting everyone's time and attention by just proposing like bogus, you know, referendums. So, okay. Maybe just for the sake of time, I'll only talk about some of these. So ensure can withdraw, that's kind of like we were saying, it's, you know, you might want to request to withdraw from someone's account. This is the one that just makes sure it happens and doesn't actually do the withdrawal. Transfer is the obvious one. This is like the most important function for a currency, right? I want to pay Jeremy some tokens, so I call the transfer function. So it's who's paying, who's receiving, how many, and then it just gives us back, you know, a result. Did it succeed or did it not? Slash we talked about a little bit for like burning someone's tokens if they did some kind of agreed upon misbehavior.
So wait, slash is just burning tokens?
Yeah, let's read it. Okay. Deducts up to value of the combined balance of who, so who is, this is what they were talking about. Preferring to deduct from the free balance. So again, if you have like a free balance and a locked balance and stuff, it's going to prefer to take the free balance first. And it says this function cannot fail. The resulting imbalance is the first item of the tuple returned. Okay, so we're giving back a tuple, and because slashing is destroying someone's tokens, that means we're going to have a negative imbalance. So like, since we destroyed some tokens, the total issuance is lower than it used to be. So now we have to throw it back to the implementation of the token to do whatever they want to do with that. Maybe something fancy, maybe something trivial.
Yeah, makes sense.
Yeah. Oh yeah. Oh, and this is something I haven't fully like internalized there. I kind of forget sometimes. As much funds as up to value will be deducted as possible. So that means like, you know, if I'm someone who only has 10 tokens and I do something that we've all agreed is requires slashing of 20 tokens, well, obviously you can't slash more tokens than I have, but it will still slash the 10 that I do have. And then it says if this value is less than you know, the value parameter that you passed in, then a non-zero second item will be returned. I'm going to skip some of these because they're sort of similar. Deposit creating adds up to value to the free balance of whoever you're trying to do it to. This is interesting because if it doesn't exist, it's created, and that's to contrast with one that I skipped over, which is deposit into existing. where they say if you try to give tokens to one that doesn't exist, then it's going to give you an error. And just to zoom out again, because we kind of got into the weeds here, what we're looking at is required methods for a currency trait. So when we go to try to implement our own currency, it can't count as a currency. It can't count as one of these like currency trait implementers unless it has all of these methods. And then I said sometimes there's a section called provided methods, which is still methods that you have to implement, except that they come with a default implementation. So you could override them providing your own if you wanted to, but in many cases you might not need to do anything special, and so the provided one would work. And so it's showing us here that, it's showing us all of the things that implement this trait, and the only one that's in this, sort of in this parity code base here is balances. So when I hover, you can see it says this is balances module that it's talking about. So I guess let's go there. Yeah. So when we look at the balances module, we can see all of these methods. Well, hopefully those look familiar. Those are, at least many of them, are the same ones that we saw that we already had to have. For example, total issuance was in there. But there's also additional methods in here, right? So like transfer fee was not required by the trait. So when you implement a trait, you can add additional methods and fancier features and everything. The trait says you have to implement blank. You're always welcome to then implement more stuff on top of that. So there's like actually a bunch of them in here, like how much does it cost to create an account, etc. All right.
Wait, but what the main difference between these two modules? One provides traits and other provides implementations?
Yeah, so yes, exactly. So right now we're actually looking at the implementation by the balances module. So we're not even looking at a module right now. In fact, we're looking we're looking specifically at the module struct that comes from SRML balances.
Yeah, and that was SRML support.
Yeah.
But I'm just curious why transfer fee isn't promoted to support module, because querying a fee is pretty useful feature.
Yeah, so your question is maybe like, where's the line? How do you decide what should be required versus what's like just an implementation?
Yeah, something like that.
That's a really good question that I don't really know an objective answer to, One way to answer it is just to say like, well, it's kind of a decision about like what's common enough and important enough. But yeah, you make a really good point, like transfer fees, that seems like a pretty common thing.
Yeah, I guess there can be currencies without fee at all.
Yeah, totally. But you can also make the exact same argument about existential deposit, right? Like we could have a currency without any existential deposit, but somehow that ended up in the
yeah, by the way.
Yeah, exactly. Okay, so let's actually jump to the code, because the one thing we were hoping to do is like look at, okay, there's this trait out here, currency, maybe I want to implement it, or maybe later I find another trait that I want to implement my own version of. So what does that look like? So let's start by just looking at something that does implement it. So I'll start in the main Substrate repo, and I like to work against v1.0 because it's just stable enough. So here's all of our SRML Substrate Runtime module library modules, and there's a bunch of them. Some of them we've talked about. So like here's contract that we worked on before, and some of these like consensus is actually gone in master now. But here's the one we were talking about just now, balances. So this is a little tiny bit off topic in terms of traits, but still useful to know. The file structure in here, there's a couple common file structures, and one is to put basically everything into lib.rs. And for small modules, that works great. Another one is what we see here, which is where you separate out your tests. So that probably makes sense. Like this whole thing is your test module, and each one of the functions is a test. And then when you write tests for a Substrate Runtime module, you have to do some mocking. Like you have to sort of like build a basic runtime. So you can see that we've done that here. And so that's usually like just 100 lines of code or so. And then the interesting part, the part that I came here to talk about, lives here in lib.rs. So lots of dot comments. Oh, so by the way, this, like, just in case anyone doesn't know, these lines that start with like / bang and some other ones that start with 3 slashes, those are what actually generate these kinds of documentation. So let me like scroll, or in fact, I'll just search for like a good place to start is deco module. There it is. Okay, so deco module is where you put all of your functions that we call them your dispatchable functions, like the ones that generally the idea is it's ones that people can call externally. So transfer goes in there. That makes total sense. If Alice wants to pay Bob, she has to be able to call the transfer function. So that's a dispatchable one. And the signature matches exactly what we knew the signature had to. So if we go back to our trait, transfer has to have a source, a destination, and a value. And so it has source, a destination, and a value. And this compact thing here, this is important for like how the value is encoded in binary format. It doesn't really affect our understanding when we're like writing the code. This just makes it take up fewer bits and make the transactions more space efficient. Okay, so transfer is dispatchable. Set balance, the description here is set the balance of a given account. So this was not in the trait. We can confirm. Yep, nothing here called set balance. And so that means that this set balance function that our balances module is implementing is not necessary, not required for the trait. But it is super duper useful when you're like playing around with your blockchain to just be able to set someone's balance arbitrarily so that people can have the right amounts of tokens that you need.
Yeah, so it's available in UI, but still remains in development mode.
Yeah, exactly. Okay, so and then that's actually the end of deco module. So that means we only have 2 dispatchable functions. And let me just show that real quick. So I like to use this UI that I think most of us have seen before. And when we go to extrinsics, if I want to submit an extrinsic to the balances module, then here's my list of all my functions I can call, and it's set balance and it's transfer. And those are the 2 that we just saw. Sorry about that. Okay, so impl module. So this is where we write all of the additional methods that are not dispatchable methods. So this is where like most of those ones this is basically where the non-mandatory ones are going to go. And then somewhere down below, we're going to implement the trait currency. So let me look for that. Oh, it's right here, actually. We found it. Great. Hold on 1 second. I just have to cough. Okay, cool. So this is the part where we're like actually telling the compiler this module that we're making right now is going to be a currency. We're implementing that currency trait so that any other module who needs a currency can use our module to fulfill that dependency. And so if you remember, we had to give it 3 types and then a whole bunch of functions. So here they are, our 3 types and our whole bunch of functions. So my goal or my thought for going into this was that when we code up our basic token here, we would kind of do like a minimum one, you know, transfers are possible, but maybe no like issuance, no burning, no locking, all that stuff. So just to start like brainstorming what some of these functions might look like. This one that says total balance of who, well, this is going to be super similar, except we're not going to have this concept of a reserved balance. So we would basically just like query storage and return the balance of that person. So like just that highlighted part could be the body. So then there's this function can slash. And even if our module, like let's say we decided, hey, we're going bare minimum, simple token, we're not going to do any slashing or anything. So question, does that mean I can just like fail to omit this or like just decide, hey, we're not slashing, so like I'm not going to write that function? So the sort of the answer is you have to write the can slash function, even if you don't intend to support slashing. And the reason is because it's in here in our trait. There it is, can slash. So our module can't be considered a currency unless we have that function. Now that doesn't mean it has to do anything interesting. Like theirs actually does something here. And so ours would just be like false. It just always returns false. You can't slash anyone because we don't support slashing. Okay. Total issuance. Oh, so they actually have a storage value for total issuance. That's a fine thing to do. Maybe we would do it that way. If you wanted to save a little bit of storage at the expense of a whole bunch of computation, this could also say something like iterate through all of the accounts that exist and add up their totals. But in a blockchain context, that's not really it's probably better to use a little bit of extra storage instead of all that extra compute for the same reasons that Kirill was talking about for the crypto in the poker game. Like you just don't want those long running computations on every block, or like on every block that has that call to total issuance. Okay, minimum balance, we talked about that. If our, so that what they did here was just query storage, like there's a hard-coded value in storage that says the minimum balance. If we decided like, hey, you know, again, dead simple, no minimum balance, then we could just literally write a 0 in here. So minimum balance is 0. This is the one that checks people's balances. So this is basically always going to look the same. We're just going to look it up in storage and see who has that particular value. All right, now ensure can withdraw. Now this one's kind of complex in here, and that's because they're doing some fancy stuff. They're talking about like withdraw reasons. So they have this enum of all the different reasons why you can withdraw something. So one reason I might want to withdraw someone's tokens is to reserve them. Another, you know, pretty obvious reason is because they're being transferred over to another account. And there were a few more. And so now that we're talking about withdraw reasons, and I'm like, oh shoot, I can't remember all the withdraw reasons. This is a perfect opportunity to go back here and, oops, sorry about that. And look for withdraw reasons. There we go. Oh, this is the one I want. So it's an enum. That means that there's like several alternatives, and we looked at a few of them. So we looked at reserve, and we looked at transfer. Oh, transaction payment, sure, for a system fee. And then they have a different one for fee also, just for, you know, like what's an example? Oh, like here's a perfect example. Like maybe we're writing that poker game, and there's some kind of rules like you every time
it fits
into the casino or
there is ante in poker.
Oh yeah, perfect, yeah, good, exactly. So you know, we could use this withdraw reason, or we could make our own enum that has withdraw reasons, or we could just say like, hey, we don't really care what the reason is, that's nobody's business except the withdrawer, and just remove that logic entirely if we wanted to. So okay, so anyway, just to like dig into their implementation here, we're basically asking the question like, can we withdraw this certain amount from a specific account for a specific reason? And so this is saying like, if the reason is to reserve or to transfer, and the balance of who is greater than this proposed new balance, then we're going to give an error. Vesting balance too high to send value. So there's some more logic, and let's see, lock.is is empty. I don't know enough about the lock implementation, I guess. Okay, so transfer. So here's an important function. So we're saying basically like, often this first parameter is called origin, but here we're calling it the transactor, like the person who's choosing to send some tokens, and then who we're sending to, etc. So we've seen that before. So, oh yeah, so in Substrate, while we're here, it's good to say this, like there's this common pattern that you have to follow, which is you have to make sure that you're not going to have any errors, like that this thing you're about to do is going to go through successfully. And if it's not, you have to throw an error before you modify any of the storage state. Because the second you throw an error, like here, for example, there's an error, got overflow after adding a fee to value. or here's a more straightforward error, balance too low, right? Like I tried to send 10 tokens when I only had 5. Well, if you think about what it looks like to send tokens, there's lots of ways you could do it. Like if I'm gonna send Kirill 10 tokens, you could like subtract my balance, then add to his, or you could add to his, then subtract from mine. But the bottom line is you have to make sure none of those things are going to error out before you make any changes to storage, because those aren't going to get rolled back. And so if you're used to writing contracts in Ethereum or something like that, that's maybe a little bit something to be more mindful of, right? Do your error checking first. So let's see. It might seem kind of funny, like it's totally straightforward to say like, oh, you don't have enough tokens to transfer some. That makes sense. It might seem a little bit funny to say like, oh, the recipient has too many tokens, you can't give them any more. But here we're using integers that only have a specific number of bits, right? And so like, if you have almost the maximum value of tokens and then I give you like 10 more, that might overflow yours and take you back down to, just barely over 0, and the recipient definitely doesn't want that to happen. So that's something we're checking for here. So let's see. It looks like once we get past destination balance too high, yeah. So where's the part where we actually make the transfer? Oh, right. If we need to make a new account, then we make a new account. And so, okay, so then finally here it is. We set the free balance of the destination to the new balance that we calculated somewhere right up here. And, oh, where's the part where we detracted? Oh, right here. Here's the part where we subtracted from whoever's sending the token.
Wait, but this branch creates new account, but how can we send somebody money without knowing its account if it's not exist?
Oh, okay. So that's a good idea, or a good question. So like anyone can, in fact, let's do this right now. Anyone can do this. There's two different notions of an account existing, kind of. One is like someone knows the key pair, right? Like I can do some crypto here on my side locally, generate a key pair, tell you my public key and my address. And so like in some sense, my account kind of exists now, right? Like you have all the information you need to try to send me tokens.
Mm-hmm.
But a different notion in which account could exist is that the storage for the balance module actually has my entry in the mapping. So like phase 1, sorry, I have to move the videos so I can see the whole screen. So phase 1 is if I want to come create an account on the accounts tab, and I do add account, and I just, let's say like this is Joshi2, and I put my super secure password in here and everything. So, and this is just a joke account, so I'm not going to actually save it. But like, I could send you this address and you could call transfer to try to send me some tokens.
Yeah, but this account is already created or not?
No, from the crypto perspective of like, I know the information and the public half of the information. In that sense,
okay, so it's account in our human meaning.
Exactly. But it doesn't yet exist in the balance module's storage. Okay.
Yeah, this makes sense. I guess there are several additional storages, and they sort of initialized when we make first transfer.
Exactly. And you can even imagine like if there's a bunch of other modules in this runtime, let's say there's like some just poll, like we're voting on some silly, like what's the coolest car or something like that. Like I might have interacted with that module a bunch, and so my account ID is all over its storage, but I've never actually had any tokens, so it's not in the balance module storage yet.
Yeah, makes sense.
Okay. So we don't need to go through all of these, but the point is like they're going through each one of these functions and they're starting to implement them. And this block that we're looking at, again, this is the one where we're saying impl currency for module. So let me find that line again, this line right here. Oh no, sorry, that is not the line I wanted. This is the line I wanted. So and there's, currency has like a lot of genericness or genericity or whatever that word is. And it's kind of cool, but it's also makes it a little more complicated to read. And so the idea with this instance thing is that you might want to have a blockchain that has like more than one currency, right? You might not want just your one like main token. You might want 2 or 3 or 10 tokens. And so the currency module, or sorry, it's called balances. The balances module actually supports having multiple instances installed. And so that's why we have this like extra stuff that we haven't seen before. So, okay, so let's look at what it would look like to start generating these. And definitely we're not going to get through it, but that's okay. So I have this project here, and I'm a little far in, so I'm going to Control Z to undo some of this stuff. And okay, perfect. So I'm back to just basically a plain node template. So actually, I'll show this. I'll show this repository because it's
Yeah, sure.
Wait, here's where it is though. GitHub, and it's on my colleague Sean's GitHub right now. So for those of you who were here last week, Sean is the other guy that was from Parity. Yeah, this guy. And he has one called. I think it's called Substrate Module.
Substrate template.
Yeah, this one. Oh,
package or model?
Did you use this one?
No.
Oh, yeah.
I used Substrate package, but.
Oh, Substrate package is a good one too. Yeah, so Substrate package is basically like the whole Substrate repository and the user interface, and they're all with known versions that are known to work well together, which is
easiest way to start.
Yeah, yes, it's so much to follow a tutorial and not get stuck because like, a new version came out 6 minutes ago or something like that. This is a different repository though, and this one is basically like a minimal module, and it goes along with another tutorial that I wrote over here back in substrate.dev tutorials, and it's this one. Write a runtime module in its own crate. So most of the tutorials early on had you, when you're writing your own module, they had you basically like copying the node template and then writing your module directly there in the template. But that makes it super hard for other people to use your module if they want to, because all the code's like right there mixed in with your node and everything. So I wrote this tutorial about writing a module in your own crate, and then Sean said like, hey, we can make this way easier by just having a template repository that does exactly that. So this is like, if we look at the main file here, lib.rs, this is really just a template module. Like you've probably seen this before, like a dummy storage item. It's the same old module template that we've used all along, but it now lives in its own crate. So I've cloned this thing down here, and I have it in my repository now.
So it's like Substrate package, but purified for writing module and copy pasting its Substrate repo, and it works like with version 1.0 out of the
Yeah, so it's unlike Substrate package, it follows along with 1.0. But it is a similar kind of concept. So like in my left panel here, this is a whole node template. Like I've got the runtime and the source. Like this is how node template always looks. I've got this stuff where I can like specify my Genesis parameters and all that. Like this is a full blockchain node. And then the green folder here, simple token, this is where I cloned Sean's template module. So what I've done is oh, sorry, I got myself a little bit lost. So I cloned this module right here, Substrate module template, into this folder simple token. And then the only other change that I've made, wait, where is that? The only other change that I've made is here in its cargo.toml. So I named it simple token and I changed it from his name to my name. So what I'm going to do now, and I haven't done this yet because I was going to do it here in the session. When I'm ready to use this thing, I'm going to come back into my runtime in cargo.toml, and I'm going to add like this, dependencies.simpleToken, and then most of this will be this sort of similar. Default features is always false, and then I'll do path equals / simple token.
Can you hear me?
Yeah, I hear you, Jeremy.
Sweet, got it to work. Real quick, can you explain the default features real quick?
Yeah, yes. So this is default features. This is getting a little bit into, well, yeah, it's worth doing. So, so there's this section of cargo.toml called features. So in general, Rust crates can have several features, and you can specify one of them as default, or maybe a couple of them as default. I think we could do like, you know, feature 2, feature 3, like whatever they are. And basically what that means is like, if I build this Rust project just with cargo build or something, a certain number of like these features that I've specified here will be built by default. And then if I want to, I can do like, you know, specify flags, like also build this other feature that's not default, or like, you know, don't build feature 2 or something. But default just says like, hey, when you just run cargo build or cargo build release, all of these features, in this case, just STD, are going to be included.
Gotcha. Now, thank you so much.
Yeah, no problem. So STD stands for like this standard. And what we've done here then is we've said like, when we build this standard feature, also build the standard features of all of the modules that I depend on. So for example, you can see like we're going to build aura STD. So somewhere down here we have dependencies.aura. That's that one. Yeah. And so, okay, yeah. And so basically like what I'm saying here is don't build those default features. Okay. So the beauty of doing it this way is that like I'm writing SimpleToken in its totally own package. So I could like publish it to crates.io. I can put it in its own GitHub repository. And then whenever someone comes along and says like, yeah, you know, I do want a SimpleToken and maybe balances is a little too much, or for whatever reason I want to use SimpleToken, then they can just include it. Like for me, I have it right here on my local system like hard drive. So I just did this. But another thing you can do, like once I put it on GitHub, is, you know, maybe it would be like github.com/me, oops, /SimpleToken or whatever. So it's just kind of a nice way to be a little bit more modular, especially since we're calling them Substrate Runtime modules, so that they don't all have to live in the same repo. And then you can do, you know, you can specify like tag equals v3, or you can do it by branch, or you can do it the way that we've done with all of these other ones down here, where we say revision equals whatever your commit was, your commit hash. So, okay, so that gets us up to speed with where we are. I've cloned Sean's like template module. And what we're going to do now is we're just going to go ahead and take the first few steps toward implementing this currency trait. So the first thing we have to do is actually just like get the currency trait into scope, right? Because if we want to say like, dear compiler, this thing I'm writing is a currency, it's going to be like, yo, what's a currency? So here's how we do that. Use, and then if you can't, I happen to remember where it came from because I just did this in preparation, but like in general, it's kind of hard to remember where all those things come from. So that's what this is for. And so we see here it comes from SRML support traits currency. And we've aliased SRML support to just be called support. Oops, not crates, traits. Okay, nice. And then I guess since I mentioned it, it's worth giving the full details. Like, how would one know that this was called support instead of SRML support? That comes from the cargo.toml here. So you can see that the package itself is actually called SRML support, but we've chosen to locally call it just plain support. So that I have kind of mixed feelings about that. I think it's cool that you can give it your own local names if you don't like the names that the author gave it. But I also think sometimes it's confusing that we like rename SRML support to support. But now we've talked about it, so people get it.
Yeah, it could be confusing sometimes.
Yeah.
But
yeah,
helpfully if some dependencies have the same name.
Yeah, yeah.
I guess.
I remember when I was like brand new on Substrate, I was following some tutorial and it was telling me to bring in SRML support. You know, I don't even remember what it was. And I typed like the full name instead of the local name and got some error. And I was like, oh, I'm so confused. But it's just one of those things, like once you learn where those things live and get familiar with cargo, then like, you know, it's pretty easy to deal with. So I guess let's just compile it and see what happens at this point. Like probably not anything too interesting. so it gives me, it compiled successfully. That's great because I hardly changed anything. And it gives us this warning that I've included this currency trait, but I never used it. And that makes total sense because we haven't implemented it yet. So I guess the next thing we could do, we know that we're definitely going to need some balances here. So let's go ahead and add a storage value. And so the syntax here is the name of the storage value that whatever you want to call it. So I'm going to call it mapping, or I'm going to call it balances. And then there's a couple optional things we can put in here. One of them is get. And if you use get, it's just going to save you the effort of having to manually write a function later that does nothing except read storage and return it. So I'm going to call it like balance of. So now I'm automatically going to have a function called balance of, and it's going to tell me whoever, like the person's balance. So it's going to have a type, and it's a map. And I think I remember the syntax, but I'll double check later just to be sure. So what we want to do here is we want to map account IDs to you know, something that's going to end up being a balance. And so for now, let's just call it like an unsigned 32-bit integer. And then I think at some point we might want to like update this to t balance. I don't remember exactly where that's going to have to happen, but what I'm getting at here is that we already learned when you make a currency, you have to give it this type called balance. And so instead of like, you know, telling it, hey, balance is U32, and then by the way, also this thing is U32, it's better to just tell it like this thing is t balance. But since I haven't defined this yet, it isn't gonna, like I can't type that there yet. So let's see if I got the syntax right. Oh, that was a fast compile. Yay, I did get it right. Okay, good. So now we have this mapping of each person's account ID over to their, you know, whatever, like their number of tokens. And we can probably get rid of this part from the node template. And we just have to then comment out the part where we use it too. So slowly transitioning from template into something that's an actual currency. So that looks good. Okay, so, you know, like so far everything's going pretty good. When I was doing this in preparation, my next step was to say like, okay, let's look at the balances module again, and let's basically just copy this big block of code here, and then go back and modify each one of these functions to suit our own needs. And I, you know, forewarning, like spoiler alert, I did get a little bit stuck because of that positive imbalance and negative imbalance stuff, but it's, I think, still worth showing. All right, so there's the end of that thing. Oh, and while we're here, look at this. So again, this is the balances module code again. And so it also implements other traits. So balances is a, you know, a big full-featured module. It's not just currency. It's also reservable currency, and somewhere down below it's lockable currency. So your module can provide as many of these traits as it wants to. And they don't even have to be similar traits. Like obviously currency, reservable currency, lockable currency, those all are like kind of similar in nature. But if you have a module that provides like 2 or 3 different facets, you could make each one of those its own trait. And then people who glue these modules together in their runtime, they have a lot of customizability in terms of like, oh, maybe I want to use your module for one of these traits, but like a different one for a different trait. So anyway, okay, I copied all of the implementation of currency, and we're gonna, whoops, we're gonna paste it in here, not in the test module, but like here, I guess. So that basically tripled the size of our file, and as you can guess, we'll get some errors here. And most of them are fairly straightforward and like teach us interesting things. So let's just take a peek. So the first one is, oh, we looked at this earlier. With withdraw reason, use of undeclared type or module withdraw reason. So there's a couple ways we can handle this. One way is to just use the one that already exists by putting it in here. I think that's how it's spelled. And then we can see if we solve that error? Yeah, we did. So our first error doesn't happen until line 151 now. But there's also other ways that we can do that. Like, I think we can just write our own here. Whoops, that's not how you spell it. And now we just give it variance and like, you know, for fun, maybe that's why I withdrew, or because I felt like it, or whatever. And you know, obviously these are silly, and you should like have real thought into what you're doing. But the point we're making now is just that like we can write our own. So let's see what the compiler tells us now. Oh yeah, just same thing as before. Which is on line 156, this negative imbalance stuff. So I don't know enough about how to solve that. I'm not even going to like try to dive into it now. We talked about what the purpose is and why we have it and why it's important. But I'll just show you how some of this looks in the actual balances module. That's not where I wanted to be. There's a bunch of stuff about like subtraits, and this gets there. This is what I was looking for. So yeah, so there's this whole sub module inside of balance is called imbalances, and then it has this structure positive imbalance, and then there's another one down here that you probably expected, negative imbalance. And it's like just complicated enough that I never really figured out like, where does positive imbalance map back to something super concrete, like an actual, you know, integer or something? So it's definitely in here, and I'll study this more, but I think we would probably get a little bogged down in details doing that right at the moment. So let's skip that part for now, and let's just go into, oh, it's actually already a little bit past. So okay, let me just write one of these functions, and then we'll stop it for today. So let's say, let's go Bitcoin style and say total issuance is 21 million. Really cool thing about Rust, you can write number literals with underscores in there, and it makes it a lot easier to read than when you just have like so many zeros that you can't tell, you know, is that 4 or 5 or 10 zeros or whatever. And since that one was easy enough, we'll do this. We'll say like, hey, our token is super simple. There's no minimum balance. We'll just make that 0. Free balance, that oh, we would have to change this because we didn't call our storage item free balance. We called it either balance or balances. Let me check. I think balances, yeah. Okay, so there's a couple little modifications and still a bunch of errors in there. So we got a little bit of the ways in here, and I think we talked about a lot of important concepts and saw a lot of important details about how one starts to implement one of these traits. I also think that currency might be just a tiny bit too complicated of a trait to start with. So let me close by showing you guys this issue. On our Substrate Developers Hub, there's an open issue called this one, a guide for creating swappable modules. And so I'm going to work on this, unless Sean beats me to it, but one of us is going to work on this. And it's going to teach basically exactly what we went over now. And so we'll either finish this example that we started here, or more likely come up with some trait of our own that's a little bit simpler than balances, that maybe has like one associated type and a couple of required functions or methods. And then we'll show like 1 or 2 different implementations and how to swap out those implementations. So the end goal is to say like, okay, imagine you're someone who wants to build a blockchain and you know you need some notion of X. Maybe X is like voting. And here's 2 different implementations of voting, and watch how easy it is to swap one for the other because they both satisfy the same trait. So, okay, so I guess we'll end there. Let me just say, like, does anybody else have any questions or final thoughts or anything that they'd like to share?
No, not really. It was really cool. I think that the one that you are saying, the issue that you are going to be working on will be very, very useful.
Yeah, totally. And so, and like always, this is a public issue queue. And so if anybody like is thinking like, oh, I think I learned just enough today that I might kind of understand this, feel free to jump in. And, you know, even if you only get 10% of the way through and then you're stuck, like, I know this is true for me, and I think it's true for Sean too, that like when someone else has tried it, that's like a huge motivation to like try to help out or keep it going. So contributions are certainly welcome. Yeah. All right. Well, thanks everybody for attending again. It's fun as always, and I hope to see you guys all back here in 2 weeks.
Yeah, thanks, Josh.
Yeah, you're welcome. All right.
Thank you.
Bye.
Bye.